So let's talk a little bit about identities, directory services, and single sign-on. When we talk about identity, we're talking about what uniquely defines you. Is it your name, your birthday? Well, those things are pretty common. It's easy enough to find someone else with your name or your birthday. What about your personality and your experiences? Well, that's more unique, but it's difficult to define those properties, and you really can't track them. Plus, they're always changing. How can you really define somebody by something that's constantly changing? Well, what about DNA or fingerprints then? Well, in the case of identical twins, they have the same DNA. Surprisingly, however, twins don't have the same fingerprints. It's not strictly a genetic trait. Now, Gottfried Leibniz gives us this great law of indiscernible identities that says, there cannot be separate objects or entities that have all their properties in common. Well, what does this mean? It means that if we define an object or entity by the properties it has, and two objects have identical properties, then they become indiscernible from each other. There's no good way to discern or identify one object from the other if they are identical in all the properties that are being tracked. And to give you an example, let's take a look at these two objects. We can see right away that these objects are vastly different and nothing like each other. However, if we attempt to define them as having the properties of being a ball, being round, something that bounces, something that's orange in color, and perhaps something that's used in a sport or a game, we would be describing both of these. We're not giving any information that helps to discern one from the other. So the law of indiscernible identities really isn't about saying that the objects actually are the same. What it's saying is that we're not tracking enough information or the correct properties to properly discern these two. We need some sort of unique identification of a particular entity or object so that we can tell it apart from others, whether they're dissimilar or not. It can be very difficult to do this because you need to pick the property or group of properties that's guaranteed to never have any overlap or duplication with another object or entity. So how do you go about solving that, at least from a computer systems point of view? Take, for example, the U.S. government, who has solved this problem with something like a Social Security number. Rather than trying to take a combination of existing properties to uniquely identify somebody, they just decided to issue something that's unique. This is the way it's handled in a lot of systems now, so if I'm in control of the properties to be tracked, and I know I can create a property that will never be duplicated, I can issue that to identities and then use that to discern them from each other. So in the computer systems world, you can now have an identity that's defined by a unique ID number, although it doesn't technically have to be a number, it can be anything that includes letters or symbols. So in the computer systems world, you can have an entity now that's defined by a unique ID number. Although it doesn't technically have to be a number, it can be anything, including letters or symbols. And all of the properties that we normally use to describe ourselves are stored as pieces of information called attributes. And the combination of your uniquely identifiable information and all your attributes are stored together as a user object in a user database. So now we know what constitutes an identity in a user object. Let's talk about schemas. Schemas are nothing more than a list of attributes that are maintained by a system. You might be one person, but you could have identities in multiple databases. Perhaps you have a social security number and also a driver's license. Well, these are two different systems that track different properties or attributes about you, and that means they have different schemas, and these differences will become important to understand when we look to associate or link identities between multiple systems. So, for example, there are times we may need to copy information from an identity in one system to an identity in another system. Perhaps we're trying to merge two companies together and they maintain different databases with different schemas. So the first system uses a system-generated numerical identifier, and the second system uses an email address as its unique identifier. Notice that the first system tracks certain information separately, like name and address, while the second system combines that information into singular attributes. Notice too that both systems track email address, but they name the attribute differently. So when we try to link these systems together or copy information from one system to the other, a certain amount of manual work will need to be done first. We need to map or associate certain attributes in System 1 with attributes in System 2. Sometimes this can be done automatically if they're named the same, but other times it must be done manually. Also, we may need to do some sort of data manipulation or transformation by taking information such as the first and last name and combining it to insert it into the name field on the second system. Or in the case of the address, we may need to insert commas or spaces in addition to combining the elements in order to properly format it. Notice also that the unique identifier is not one of the attributes copied. Generally speaking, you cannot copy a unique ID from one system to another. The ID is generated during the user creation process and usually cannot be altered. Another thing we must watch out for is the potential for violating constraints. So there may be certain rules or requirements for data in system number 2. For example, if system number 2 does not allow for any numbers in its name, what will happen to users in system 1 that have numbers in their name if those users are copied over? Will the resulting name in system 2 be left blank, or will it only copy some of the data, or will the whole copy process for the user be rejected? It depends on how the system reacts. What if system 2 only allows for an address with 30 characters, and yet if you add up street, city, and zip in system 1, it's 40 characters long? What if the phone number is required for users in system number 2, but there's nothing in system number 1 that matches to that? So as you can see, it's very easy for users in system 1 to be unable to be copied to system 2. Therefore, it's important we do a lot of testing and validation before the copy process. Otherwise, you run the risk of errors and incomplete information in the resulting system. While we're on the topic of schemas, it's worth discussing what it is to extend the schema. And extending the schema is nothing more than adding new attributes to user objects or modifying existing ones. Let's say we decided during the merger that we wanted to maintain 2 separate user databases because they were just too dissimilar to combine. What if we now need to track new information? So let's say we wanted to track for each user the office they were located in, the floor that they were on, and the printer that they were assigned. Even though these 2 schemas are different, we can extend them in the same way by adding the same additional attributes to each. So the schema in a user database are not necessarily fixed and can be adjusted when needed. A common example of this is with Microsoft Exchange. In many corporate environments, they use Microsoft Active Directory as a means to track users on the internal network. Active Directory has a schema like any other system that has a user database. But when you want to install Microsoft Exchange, which is an email server, there's additional information that needs to be tracked and associated with each user. Therefore, before you can install Microsoft Exchange, there's a requirement to extend the Active Directory schema. And this means certain tools will have to be run before the Exchange installation is carried out. These tools come with Microsoft Exchange, but they are separate from the installation process and must be run in advance. The idea here is to add or modify the existing attributes to account for various information that Exchange will need to keep track of. So now that we have a user and a user object stored in a user object database, it's time to talk about directory services, authentication, and resource access. So in addition to user objects, there's also objects for resources and objects for devices. A server that maintains a list of all of these objects is called a directory server, or sometimes a catalog server. If the server allows you to perform lookups or reads and writes, then it's said to be offering directory services. When a user requests authentication or logs on to a network, what it's really doing is requesting to be associated with a user object that's listed in the directory. Technically, it isn't the directory server that performs the authentication, it's the authentication server, but sometimes these two are one and the same, or at least located on the same hardware. The mechanics of authentication are not important for our purposes, but the point is that the user object has to exist in the directory for authentication to be successful. Once authentication succeeds, the user is granted a ticket or a token or something that it can present to resources to show that it is authenticated as a user. So for example, if you tried to access a file and the file was restricted to only certain users, it would check your token to see what user in the directory you've been associated with and if that user account has permission.